Hello, my name is Carla Alcaraz and I am an undergraduate at San Diego State University. I am part of the SACNAS SDSU chapter. I want to give a shout out to Lawrence K. in Albuquerque who asked, "What's behind a pink moon?" Thank you for your question. Let's begin. You might have had the chance to witness a supermoon known commonly as a pink moon. A supermoon is an astronomical phenomenon in which the Earth's moon is full and on the opposite side of the Earth from the Sun, a state known as syzygy. It is at this point that the full moon is closest to our planet Earth, a state known as perigee, scientifically known as a perigee-syzygy moon. A supermoon can appear up to 14% larger and 30% brighter than a regular full moon. Our ancestors and many indigenous peoples today continue to use full moons under different names to reflect the changes in seasons and months. As you might have seen, the pink moon is not actually pink. April's full moon is always named the pink moon because of the moss-pink flowers, scientifically known as Phlox subulata, that bloom during early spring. These flowers are native to Central and Eastern North America. It is also known under a variety of different names such as the sprouting grass moon, the egg moon, and the fish moon. Also known as the Paschal moon, it helps set the date for Christian holiday known as Easter, which is then celebrated the following first Sunday after the full moon. Don't worry if you missed this year's pink moon, you'll have a chance to see it next year.
Hi everyone, my name is Professor Adam Bergasser. I'm an astrophysicist at UC San Diego, and I'm here to speak on behalf of the Fleet Science Center and their Ask a Fleetster program. The question, what can an undergraduate astrophysics major look forward to on entry level? Well, I think that means what can we expect as an undergraduate major, and I'm really happy to answer this question because I'm very excited to hear students getting involved in astronomy at the undergraduate level. So I think there's actually 5 things that are very useful to look forward to or to prepare for as you're becoming an undergraduate astrophysics major. And the first one is built into the word astrophysics. That is the physics part of it. Whether you are studying the orbits of stars orbiting around each other, or the expansion of the universe, or the radiation from a supernova, all of these processes are anchored in basic physical processes. So in order to study the stars in the universe, we need to actually understand the physics that's behind them. So you can expect as an undergraduate major to at least be taking a full range of courses in the 4 core areas of physics, and that's classical mechanics, electricity and magnetism, which includes radiation, quantum mechanics, which is the physics of the small particles, and also thermodynamics, which is the physics of large systems, and the universe is a pretty large system. You may also be interested in doing other physics if your areas of research or areas of interest enter other areas of the universe. So for example, if you're interested in black holes or cosmology, you might need to know something about general or special relativity. And if you want to study cosmology, you may also need to know something about particle physics, particularly if you're interested in issues of dark matter and dark energy. And then if you are interested in the interstellar medium or the atmospheres of stars and planets, chemistry becomes an important area to get interested in. And if you're interested in astrobiology, which is the study of life in the universe, then of course biology, but also geology may be very useful topics to get involved in. So you can see there's a lot of physics that are involved, but also other areas of science that are something you look forward to learning in order to study the universe. Now, the other thing you need to do for studying is, of course, mathematics. That's another important topic. As an astrophysicist, I often use lots of math in my daily life, and that includes areas of calculus and linear algebra. I'd say those are the big 2, but of course, you should also know your trigonometry and geometry, and of course, basic algebra as well. Now, again, if you want to pursue specific topics, you might have to research other more advanced topics in mathematics. So for example, again, if you're interested in black holes or cosmology, you might need to learn a little bit about differential geometry, geometry on curved surfaces and curved volumes. And then there's also, if you're interested in large data sets or simulations, then having statistical analysis background and even machine learning tools to understand those big data sets might be an area that you want to get some mathematical training in as well. Now that brings me to my third area, which is programming. Astronomers work with data, and In order to work with data, you have to have some skills in programming because most of our work is done in digital formats. So whether you're looking at imaging or spectral data from a telescope or large catalogs of sources, or even if you are dealing with a theory that you want to make a simulation to represent those ideas, all of these areas require some skills in programming. Now, currently, one of the more popular languages in astronomy is Python, which is great because it's also applicable in the general industry at large as well. So learning Python helps you not just in astronomy, but perhaps other future jobs. But if you have other language experience, such as C or Java or even Fortran, then it's great because you can still get involved in data analysis, and it's actually very easy to switch over to a new language once you've learned one already. So make sure you get some programming experience or look forward to some programming experience during your studies as an astrophysics major. Now that brings me to the fourth area, which you got to put that research skills to work by doing research. And there's lots of opportunities to do research. In fact, I strongly encourage you as an astrophysics major to get involved in research early because the best way to learn astronomy is to do astronomy. And fortunately, there's lots of opportunities to do that. You might find that there's a professor or a research scientist at your home institution that's looking for a volunteer to work on a data set or do some analysis. There's also opportunities regionally. Sometimes a local observatory or a local research institution does also have openings for research students to get involved in research at a limited time, maybe over the summer or maybe over the academic year. One of the best ways to get involved in research is to do a summer research program, and there's lots of different scales of these research programs, including local programs like the UCSD STARS program, for example, but also national programs like the National Science Foundation Research Experience for Undergraduates. The applications for these programs are between January and March, and one of the great things about getting involved in them is that you get paid over the summer to do research. That's amazing, right? So not only do you get some experience and skills and some, ways of playing with astronomy, but you also can do this as a job over the summer. So definitely take a look at those opportunities when you're starting to think to be about an astrophysics undergraduate major. Now, I think that was 4. So number 5 is make sure that you are keeping up to date on what's new in astronomy. It's a big universe. New discoveries are happening all the time. Lots of exciting things happen as new telescopes and new satellites go up. And how do you keep track of all these things? Well, there's lots of ways you can do that. I recommend looking at the astronomy picture of the day on a daily basis. These are beautiful pictures of the universe taken by all sorts of people and satellites, and also a little description about what's happening in that picture. So that's a good broad way of seeing other different topics of astronomy. You can also take a look at the NASA websites and the website of the American Astronomical Society. And if you want to get involved in what's really on the cutting edge of astronomy, there's a great program by the Astronomical Society called Astrobytes, which gives nice sort of one web page descriptions of a recent paper and a format that you can actually understand and know what's going on while it's still the most cutting edge research. So there's lots of ways to get involved, and I recommend preparing for all of these different topics to be studying, but also to get involved in research as soon as possible, because that's how you can get really excited about the astronomy community. And of course, you can always check back on the Fleet Science Center website for future events that are related to astronomy, where you can learn more there as well. Again, this is Professor Adam Burgasser, and I thank you for joining in. I hope that answered your question.